Hi, everyone, and welcome to what's known as Support Library. My name is Chris Baines, and I'm an engineer on the Developer Relations team.
Hi, my name is Ting Hui, and I am engineer in the Android UI Toolkit team.
I'm Alan Viverette, and I'm tech lead for the Support Library project. So in the past year, a lot has changed in the Support Library. We added a lot of great new features in release 23.2.0, and since then we've added a lot of bug fixes and some minor features. And today we're happy to announce the release of version 24 Alpha 3, which coincides with the Developer Preview 3 of Android N. So today we're going to be talking about some of the cool new things in Support Lib and some of the things that we can look forward to in the future. We're going to start out by talking about Support v4. So everyone's familiar with this. It's where you have compatibility shims, so you don't have to do an if version check. It also contains a bunch of helper functions and utilities that you can use to make your apps backwards compatible. As with each platform version, we've put in backports for various functions that have smart fallbacks that you can use to target new APIs on older versions. And we also have a couple of features that we'd really like to highlight today. So in Fragments, we have some lifecycle improvements. Namely, Fragment transaction now has a synchronous commit. So if you're creating an encapsulated component that's working with Fragment transactions, you can synchronously commit your transaction. If your fragment is being added, it will be added and brought to the host state immediately. You don't have to worry about ordering conflicts with other Fragment transactions. Likewise, if your fragment is being removed, it will be removed and disconnected immediately, so you can handle all of your life cycle without having to worry about ordering. This is especially useful if you're a library. So we actually use this in the view pager fragment module in the library to prevent ordering conflicts. Adam Powell is going to talk more about some of the changes to fragments in What the Fragment, which happens at 5 p.m., so make sure to check that out. We've also made some changes in notifications. In particular, we have a new conversational messaging style. So when you have, say, a Hangouts conversation that's multiple parties back and forth, that shows up in notifications and shows you snippets of the conversation. This is also supported by Where 2.0, so when you have a conversation, that shows up on your watch. We've backported this in Android, so if you have Where running on an API 18 and above device, so that's when Notification Listener was added, Notification Listener service. And you use the Notification Compat builder to build your notification, and you use messaging style. Even on an API 18 device, that'll move to the Where app, which is also using Support Library and understands that communication channel, and you'll get the messaging style on your Where device as well. We're also giving you more information about what users think of your notifications. So one thing that developers have really wanted to know for a long time is, have users block notifications from my app? So in Android N, there is now an API that lets you tell exactly that. And we've backported this to API 19, which is when users were first able to block notifications from packages. So you will get an actual value from this that reflects whether the user has blocked notifications from your app on API 19 and above. On API 18 and below, it'll just return false that the user, or sorry, true that the user has not disabled notifications. We're also giving you more information about how users rate your notifications. So if they think that your notifications are less important, or if they want to block them completely, we have a compatibility method that allows you to do that and use the API on older versions. It'll just return basically a no-op value that says your notification is normal priority. We've also made some changes in the media framework. So in API 21, for compatibility with Android Auto and Where media browsing and playback, we added the media browser service and media browser. And in Support v4, we're now bringing backported versions of those. So these are intercompatible with each other on v4 and above. So if you have an app with a media browser service that's exposing media that can be consumed by a media browser if they're both running compat from the support lib, they're also compatible with the framework implementations on 21 and above. So if you use the support library versions, they'll be maximally compatible, work with a lot of devices. For a fully functional implementation of both of these classes, you should check out the Universal Android Media Player, which is in the Google samples on GitHub. All right, and for applications that are presenting web content, you have a couple of options right now. you have an embedded web view, maybe you launch a browser instance, and these have some issues. They can be a little bit slow. If you're launching a full browser instance, you kind of bring the user out of the experience of your app. So custom tabs are a new way to present web content that we've already presented, and we're making some improvements to those. So this is new in 23.2 with some improvements in v24. The minimum SDK target for this is 15, and the reasoning for that is primarily motivated by what most apps are targeting now. So Chrome has a minimum SDK target of 16 and above. So if you're using this on API 15, likely your user's device won't have any targets, and you'll just launch the regular browser instance, or you'll need to use an embedded web view. As I mentioned, this is alternative to embedded web view that is performance-focused. So it's going to share a cache with the browser. It's also going to share cookies with the browser. So if your user is already logged into web content, that'll be persisted when your application loads that into a custom tab. And because we don't want the user to feel like they're exiting your application, we have a high level of visual customizability and navigation callbacks. So if the user leaves the content that they landed in initially, your application can perform something in response to that. So here's a quick example from the Chrome blog of how fast custom tabs is compared to some of the other solutions. Because we have a warm-up that can spin up the Chrome process in the background before you actually launch your custom tab, and because we're able to preload and pre-render content, you can have an almost instantaneous transition from your app to your web-backed content. And this is really simple to implement. So here we have an example of one-liner warming up of the Chrome process and launching a custom tab for a specific URL. One downside of this is that because we're just very quickly spinning up the Chrome process and we're not keeping any handle to it, the process may be garbage collected in the background if the system is memory pressured. So one other thing you can do is write a lot more code to create a persistent connection to a custom tab service. For my examples, I've been talking a lot about Chrome, but this can also be implemented by other browsers. So you may see Firefox custom tabs as well. But you'll need to handle connect and disconnect with your activity lifecycle here. And you can create a session. A session to the custom tab service is going to allow you to do some cool things like preloading content. So here we have one target URL that we know we're going to land on. And we have a couple of links out of that we have a pretty good chance that the user is going to land on. So as we load these, that means that we're using data. That means that we're using battery. So you don't want to just indiscriminately put thousands of URLs in this. You want to have a really good, higher than 50% confidence that the user is going to need these so that we can preload them and show them really quickly. All right, in addition to being fast, we want this to be seamless. So we provide a lot of customization aspects that you can set up when you're building your custom intent. To that end, you can customize the toolbar color. So here we've colored it teal to match our app. And you can also customize the actions. So we have a favorite action that we've added at the bottom. You can add actions to the overflow menu. And you can also set up transitions so that you have animations in and out of your activity that look like a natural extension of the rest of your app. So this is really great. It's really easy. So these are all just things that you set on your builder when you're launching your intent, and then you launch it out to the custom tabs process. And as I mentioned, this is API 15 and above if you're on older devices or devices that don't have a browser that supports custom tabs. You can also have a fallback path for either launching the browser intent for view or simply launching an embedded web view in your own application. All right, so I've covered some of the major features in recent support library history, but there are some other features that are highly anticipated that I will let Teng-Hui and Chris talk about. So over to Teng-Hui for Vector Drawable.
Thank you, Alan. Great. Before we talk about the technical details for the vector drawables, let's start with some design principles we have when we're designing these new classes. First of all, the first question we may have is like, why do we need vector graphics? As we all know, Android has been using bitmaps for a long, long time for the icons and the drawables. And as the phone and tablets grows bigger with higher resolution, those PNG files is taking more and more spaces in your APK file. And vector graphics is the perfect solution to this problem. It is using a much smaller, compact file format to represent those icons and can scale to any definition, resolution. In this example, on the left-hand side, the multiple PNG files can take up to 10 kilobytes. But on the right-hand side, we just need one single XML file to represent the same icon, which can take only 1 kilobyte. With more and more icons in your APK file, then that means you can bring down the APK size significantly. The second question we commonly get from developers is like, why do we not using SVG file format? I hope you all know the SVG is very complicated spec, and is surely an overkill for representing those simple, small icons for your Android app. Moreover, we want this newly designed drawable is consistent with all the other Android APIs, especially those animation API and theming API, and work nicely with all the other resources. So we introduced the vector drawable and animated vector drawable in Lollipop, and they work nicely for API 21 and above. And they use heavily inside Android OS to bring down our system image. And because our simple design principle, we can continue to improve the performance. On this note, I'm glad to report that on Android N release, we improved the drawing performance by 2 times faster, and the initial file parsing performance up to 5 times faster. And here is a sample of how the vector drawable's file format looks like. It's basically just a tree structure, and it's quite similar to SVG, but simpler. All the internal nodes here are the group nodes, and they are using to describing the transformation information like scaling, translation, or rotation. And the leaf nodes are the path nodes, and they are used to describe the geometry and color information. Based on this vector drawable's format, the animated vector drawable is just simply adding the object animators on top. For example, we can set the object animator to target it to one group's node to its rotation attribute, and set the value to change from 0 degree to 360 degree. And when the animation started, then you will see all the children nodes will be rotating in a circle. Also, you can add more object animators to different nodes to their different attributes to make your animation look even better. There's one caveat you may be able to see here. That means one animated vector drawable could involve multiple, sometimes even like 10 or 20 XML files. To ease the pain, we actually introduced a new XML bundle format to merge related XML files into one. This is in the latest build 2, and is also backward compatible. And here is one example. The animated vector drawable is referring to a vector drawable whose name is called icon, and sit inside a separate file. By simply changing the Android drawable attribute into this new AAPT tag, then you can cut and paste the vector drawable, the whole file, into this tag, and then you merge 2 files into one. You can do the same trick for all the object animators too. So basically, you just need one single file to represent your animated vector drawable. Then hopefully that will be easier for you to read and debug this drawable. And now I will also briefly talk about how do you generate those vector access. And luckily, we have Android Studio to help. The first thing you can use is this vector access repository dialog. In here, you can see all the material design icon library. And you can just pick one you like, and it will be saved in your drawable directory. Or if you have your own SVG files for those assets, you can also use this Vector Access Studio inside Android Studio to convert your own SVG files into the Vector Drawable XML file. Now I hope you feel you can see this new classes is useful to you. But the major questions we often get from developers is, how can we get these new classes working in the older version of Android? We know this is so important for you. We actually come up with two solutions. The first one is Gradle solution. Inside Android Studio, when you build your app, the Gradle will look at your minimum SDK version. If that's less than 21, and you also have Vector Drawable XML in your drawable directory, it will convert this XML file into multiple PNG files for different DPI automatically in a generated directory. And then the XML file will be used for API 21 and above, and the PNG file will be used for older versions. Then the best thing for this solution is simple adoption. So the only thing you need to do is to swap out the PNG assets into the XML assets. And then Gradle will do this by default, and it will check the minimum SDK version automatically. There's also some downside for this solution. There's no animated Vector Drawable support, and it's only supporting a limited features of Vector Drawable. And the last one is the generated PNG file could still sit inside your APK. So on this, we also recommend you have a separate APK supported by Play. You can have one for API 21 and above, which will only contain the XML file, and have another one for the older version, which will contain the PNG file. We know this sounds like a hybrid solution here, so we continue to work hard, and then we get out this more pure solution here, and based on support library. In version 23.2 of support library, we introduced two new classes. One is Vector Drawable Compact and Animated Vector Drawable Compact. So from the name, you can see we are supporting both static asset and the animated asset here. The best thing for this solution is it is XML files only. There's no more PNG involved at all. And the same XML format of file can be used for the support library version and the non-support library version. And it also supports the full feature set of the Vector Drawable. There's some caveat for this solution. First, you will need to turn on a special Gradle flag, which is Vector Drawable's use support library, which basically turn off the PNG generation and also have some special treatment on the Vector Drawable XML file. Second, you may also need to be aware of the API versions. For example, the Vector Drawable Compact is only backported to API 7, and the animated Vector Drawable is backported to API 11. And here is one example. I am using the support library. I manually create those assets, and it actually can run all the way back to Honeycomb. And as you can see, you have the scaling, rotating, and even like some clip masking, moving objects. And there's also some color change. I know you developers will be more creative than me. I hope you can also create more sweeter UI for your app, and without adding much overhead to your APK size. Last thing for this support library, the drawable reference is somewhat different. If you're using the old way, the image view, for example, if you're using the Android source, it may actually cause some exception in the older version of system. For this one, I actually have to ask our owner and expert of AppCompat library, Chris, to help. And he came up with a really nice solution. So now I will welcome him to talk about it. Thank you.
Hi, everyone. So Tenguiz just spoke about sort of the background behind vector drawables, why you would use them, and the benefits of actually using them. So I'm going to talk now about how you actually use them with the support library. And just one note here, I've abbreviated Vector Drawable Compat and Animated Vector Drawable Compat. So if you see it later in the slides, that's what they mean. So the first way you can use it is manually. So each class has a static method on it called create, which takes a context and a resource ID pointing to your resource. And that will manually inflate that resource and give you a drawable back. But we know that's kind of clumsy to use for two reasons. Number one, you can only use it in code. And number two, you can't actually use it from resources, which is, is the whole point. You actually have them. So we went back to the drawing board and we thought, how can we actually implement it in AppCompat? Because that has a lot of resource management in it anyway, with views and stuff. So we're thinking that's probably the best place to actually implement this feature. So we have a couple of ways of actually using it within AppCompat. We have a new attribute on image view called source compat. And that is basically it kind of supersedes Android source. And it allows vector drawables all the way back to API 7 for the static versions and 11 for the animated versions. We've also overridden the setImageResource method. So if you're using that API anyway to set drawables, you can use vector drawables back to the same API levels. Now, for anything that AppCompat inflates itself, so here's a good example of menus. When you inflate a menu in AppCompat, AppCompat is doing all of that for you. So as it is doing it, we can inject the Vector Drawable Compat class into it and load the drawable for you. So basically, we never touch the framework there, which means that you can use vectors in those resources, and they work back to API 7 and 11. Now, around 23.2, I wrote a blog post on Medium called Age of the Vectors. And that had a section in it, which there's a section called The Magic Way, which is a really bad name. But what it allows you to do is allows you to use vector drawables within drawable containers. Now, it was kind of experimental in that it doesn't work in every situation, so that's why I put a bit of a caveat around it. We had to remove it in 23.3, though, due to some issues around memory usage and also updating of configuration objects. We'll talk a little bit about why in a minute. But thankfully, we brought it back in 23.4. You'll see there's the asterisk next to it. And the reason for that is because it's no longer enabled by default. It's now disabled, which means that by default, you won't get the issues. But if you do want to use this functionality, you can manually enable it with the caveat that those issues still exist. If you have a look at the Java doc of this method, it's huge, and it tells you exactly what you're sort of letting yourself into. So the reason it has those issues is the way it works. Internally, it creates a special resources instance, but per context. Now, in reality, that's going to be per activity. Usually in your application, the resources instance, you'll usually only have one, which is reused across all of your activities and whatever else. But the way AppCompat has to work and the way it enables this feature is by using an instance per context. Now, the increase in memory usage is because of the caches that each resource instance holds. So instead of having one cache for drawables, you'll have, like, I don't know, X times activity. Now, it isn't a leak in that as soon as that activity goes away, the resource instance will go and you'll get the memory back. For most apps, it won't really be a problem. But if you have a really resource-heavy app, you may see an increase in memory. The second issue is because we also have that multiple resource instance, you can get into problems if you manually call update configuration. And that's quite an advanced call. I don't imagine many people are using it. But if you do, you probably don't want to enable this feature. So to actually use this method, this is the way I'd advise you to actually use it. It's a really lightweight method. So in each activity, just stick a static block at the top, which calls true, if you want to use the feature. It's really lightweight, so don't worry too much about it, putting it in every activity. So we talked about how to actually enable it. Let's talk about what it actually gives you. So as I said earlier, it allows you to reference vector resources and animated vector resources within drawable containers. So if you want to use a vector in a stateless drawable, or maybe a layer, or inset, or level list, or whatever it is, you can do so with this feature enabled. So here we've got an example where we're going to wrap a vector drawable in an inset drawable. Now, this is quite good, because inset drawable, if you don't actually give it any insets, is basically an invisible wrapper. So you'll basically just have the vector drawable, and the container won't actually add anything to it, which means that you can actually then use it in more places. So here we've got a text view, and you can set that wrapper as the drawable left, or it could be the right or top, or, whatever it is. But basically, you can use it in more places. Another example is a radio button. These are just two examples. Background works. There's other places as well. So that leads us nicely onto AppCompat. Now, AppCompat is designed to be a sort of kind of mini backport of the framework. So things like toolbar, the action bar, all those type of things have been backported into here, and it currently works back to API 7. So let's look at some of the things which we've added recently, so over the past 6 months. The first big thing that I like is night mode. So that allows your application to be themed light or dark based on the time of day. So here we've got an application which is opened at noon, and it's a light background with dark text. And then if a user opened that at 10 p.m., it will be inverted, so a dark background, light text, which is great for users if they're reading in bed, less glare. So there's two things you have to do to actually enable this in your app. The first is you change your theme and change it to extend from one of the theme.appcompat.day-night variants. So if you're already using like no action bar or dark action bar, we also have those variants on top of it. So it should be a straight swap. Once you've done that, great, but you need to tell AppCompat to actually enable the feature. And you do that via the setDefaultNightMode method. Now that method takes one of 4 options. The first is follow system. Now most people don't know, but night mode has been in the framework since API 8. But before Marshmallow, it was behind a couple of scenarios. You had to be in car mode and docked, if you remember what those were. In Marshmallow, the feature is actually always there, but you can't. You can enable it basically, but there's no usable, visible feature. Like there's no settings for it. So if you use this mode in AppCompat, basically we will always follow what the system is doing. The most interesting one is probably mode night auto, and that will automatically change between light and dark based on the time of day. It will look at the last known location of the device, and then try and work out a rough, approximate sunset and sunrise time, and then use that to say whether we're in day or night. So that's really nice. And then the last two, yes and no, which do exactly what you think. Basically, day mode or night mode. I wouldn't advise you use these unless you have some kind of user setting in your app, because you can achieve the same thing by just using the proper theme parents, either for dark, theme.appcompat, or for light, theme.appcompat.light. If you want to know more about this, Alan and I are talking tomorrow morning at 9 a.m. In a talk called Themes and Styles Demystified. We're going to go more into this and also generally into themes and styles. Another thing we've added in AppCompat recently is color state lists, and specifically ones with themed attributes. So these were added to the framework in Marshmallow, and we've backported them back to API 7. And now this is in 24.0, so if you're using the preview, then you'll have this functionality. Internally, AppCompat uses this a lot for drawable tints. We've managed to reduce the amount of color state list code by loads by actually moving all of it into resources. So here's an example of just a color state list. The first item references a themed attribute. In this instance, it's color control normal. Now, the really neat thing about here in the disabled item is that you can use the color, but you also have this new functionality where you can change the alpha of the color at the same time. So using the Android alpha attribute, you can modulate the alpha of the color to whatever you want. Now, it takes a float value from 0 to 1. We're just going to reference the system default for disabled. But yeah, you can set it to whatever you want. To actually use these and inflate them, we've added a new API called AppCompat Resources. So if you want to inflate these, use this method. We're going to add more stuff to this class in the future. So yeah, more coming soon. So following on from AppCompat, we have the design library. Now last year, last I/O actually, we released it as a kind of first-party take at implementing some of the components from material design. Since then, we've been in kind of bug fix mode and trying to stabilize it, but we have added some features recently. The first big one is bottom sheets. Now in spec, there are 2 types. There's persistent and modal. Persistent are when the bottom sheet is always part of your content. You can't dismiss it. So a good example is maps here, in that it shows the detail for whatever the address is or whatever. On the right, they've got the modal ones, and that's basically described as being an alternative to dialog. So let's take a quick look at what they look like. So this is the actual implementation. As you can see, as the user scrolls up and down, it collapses and expands, but you can never dismiss it. And to actually use it, the first thing you'll notice is that the parent needs to be a coordinator layout. So if you're using app bar layout and whatnot, you're all set already. And within here, you'd set the rest of your content. So in the map example, it would be a map view. And then we have our bottom sheet. Here we're using a linear layout, but it could be whatever you want. And the way you actually tell it to be a bottom sheet is by setting this special behavior on it. Now, Ian Lake wrote a great post on Medium about behaviors. So if you want to know more, go and read that first. But this is the way you actually tell it to be a bottom sheet. And then we also have an option. By default, it will just sit at the bottom at a default peak height. But you can also set it to be whatever you want. The peak height is how much it sits at the bottom when it's collapsed. The second type is modal. So as I said, it's like an alternative to dialog. So as you can see here, when the user clicks, you get this modal bottom sheet, which you can scroll and then dismiss. So we know that most people, well, we've already described them as an alternative to dialog. So the way we've tried to implement this is as simple as possible. We know that the majority of people using dialogs will probably use a dialog fragment. So we've tried to implement this using that. So you should be able to just change the superclass of any of your fragments to this new bottom sheet dialog fragment, and it will just suddenly become a bottom sheet. It's really simple to use. I've used it internally in a couple of apps, and it's nice. Once you've done that, you just create the fragment and then call .show, which is the same thing as dialog fragment. The other thing in Design Library, it's not really a feature, it's more of a bug we've fixed, is that any of the elevation handling was previously hard-coded into just for ease of implementation for last year. But we've been trying to fix it. So there are 3 scenarios on the material spec of app bar scrolling. The first is always elevated. So here the user scrolls, and regardless of the scroll position, it is always elevated, which means it casts a shadow, basically. You probably can't see it very well, but it is elevated. And then we have the second type. So here, the header is not elevated, so it's in line with the content. And then as the user scrolls and it collapses, it then becomes elevated. And then as they scroll off, it's no longer elevated. So that is implemented using a collapsing toolbar layout. But there's a third scenario on spec, which we didn't support. And that is when you have collapsing content, but you also want it to stay elevated. So we were trying to think of ways to actually implement this in a nice way. And the way we sort of fell with was stateless animator. So we now have a stateless animator which controls all of the elevation. Now this is similar to the button implementation on Material. So when you click on a button on Material, it's supposed to come to your finger and enlarge. Now that uses a stateless animator internally to actually do that. So we're choosing the same functionality. So we've added 2 states which you can use in your stateless animators to actually implement this. The first is collapsible, which means that there is collapsible content within that app bar layout. And secondly is collapsed, and that means that there is collapsible content, and it is also collapsed. So let's take a look at an example. So here we're going to implement the scenario where you want it to be elevated when it is collapsed, so the second scenario. Now this is already given to you by default. You do not need to implement this. We're just going to use this as an example to actually show you how to use the new states. So here we have 2 items within this stateless animator. The first is ran when we have some collapsible content, and it is also collapsed. So if you think back to the scenario, in that point, it needs to be elevated, which means that we animate the elevation up to 8 dip. Now, it could be any value, whatever you want. Look at spec for the actual values you should use. We're just going to use 8 dip as an example. And the second item doesn't have any states, which means it's the default item. Therefore, it'll be ran whenever the first item doesn't hold true. At this point, it is when the collapsible content is no longer collapsed. Therefore, we want to bring the elevation down to 0, and therefore it's not elevated. So as I said, you don't need to implement that. That is done by default for you, just using an example. Now, if you think back, there was that third scenario which we don't currently support. Now, that's a really simple stateless animator. It just has 1 item. So it doesn't even look at the states, and it just sets the elevation to 8 dip. So that's all it does. To actually use this, you just set the stateless animator tag on your layouts, pointing to whatever stateless animator you want. And now we're going to hand over to Alan to talk about some of the sneaky new stuff we're going to be planning.
All right, thanks, Chris. All right, so Chet was kind enough to tease that we're telling you about future things in Support Library this morning. So let's start out with a little interactive part. First, a show of hands. How many developers here are using the Support Library? Good, that's probably why you're here. All right, show of hands. Keep hand up if you're supporting API 14 and above in your application, or or lower, 14 and above. Okay, hands up again. We're getting exercise. If you support API 9 and above in your application. Okay, fewer people. API 4 and above in your application. Wow, not a single one guy, one girl. That's fantastic. That's dedication to your craft. I respect that. You're not going to like where this is going. We are dropping support for APIs below 9. This has been a long time coming. So less than, it's only API 9. Don't get too excited. So less than 0.1% of devices that have access to Play Store are supporting APIs less than, or running APIs less than 9. So dropping support means, one, we have fewer methods, so we're taking a couple of steps back from your ProGuard dex limit. Yeah, so about 130 methods right now, just removed from v4. We're still in the process of backing things out. This is also going to improve our release cycle. So we're able to now focus on the same platforms that you actually care about. As it turns out, supporting API 4 takes a lot more effort than supporting API 9 or 14, which is why most people here aren't supporting API 4. So we're going to be able to iterate faster. We're going to be able to focus our fixes and our workarounds for platform bugs and our testing on the APIs that you actually care about. So hopefully that'll make your life a little bit better. Second, as I mentioned earlier, support v4 contains backwards compatibility shims. So this is so you don't have to wrap everything with a version check and then figure out some reasonable fallback behavior. Support v4 started out only containing this. And then we added some other things. So we added fragments in API 11. We figured it'd be good to have a backwards compatible way to get people on board with fragments supporting older devices. And then we added some helpers for things like accessibility and drag and drop. And then we added some more stuff and some more stuff. And support v4 alone has become a very large library. So we're going to be breaking that up into more focused modules. And the important thing here is that we're going to hold your hand through this process. So we're not changing any of the package names. I should also mention for the minimum version change, we're not changing any of the package names. So support v4 is still support v4. Support v4.media is still support v4.media. We're going to be moving them into different modules, and we will have a meta module that includes everything under the old name. So all of the libraries that you use that depend on the package naming structure and the package names themselves, the module names themselves will be fine. We're not going to end up in a situation where you need a special version of a library dependency. Let's see. So hopefully this is going to be completely source code compatible and binary compatible with your existing applications and library jars. And hopefully this is going to make your life as a developer a little bit easier. So, thanks everybody for coming. We have some other talks that you may be interested in. What the Fragment today at 5, data binding, and recycler view. Thanks again, everyone. We'll see you around.